Hello friends, let us understand Kirchhoff's second law. Kirchhoff's second law. Kirchhoff's second law states that the summation of changes in the potential while traversing the entire closed loop is equal to 0. Once again, Kirchhoff's second law says that the summation of changes in the potential while traversing the entire closed loop is equal to 0. To understand Kirchhoff's law, we require to understand something which is called as sign convention. Right? Now, while traversing the loop in the direction of the current, this is the direction of the current and we are traversing the loop in the direction of the current. The potential difference across the resistor will be considered to be negative, right? While traversing the loop in the direction of the current, the potential difference across the resistance will be considered to be negative. Whereas, while traversing the loop opposite to the direction of the current, the potential difference across this resistor will be considered to be positive. Right? Okay. While traversing the loop, if we are coming out of the negative terminal of this battery, then the EMF of this battery will be considered to be negative. For example, if the EMF of this battery is 2 volt, it will be considered to be negative 2 volt. Whereas, while traversing the loop, if we are coming out of the positive terminal of this battery, then the EMF of this battery will be considered to be positive. So, if the EMF of the battery is 2 volt, it will be considered to be positive 2 volt. Right? Now, let us take an example to understand Kirchhoff's second law after we have understood the sign convention. So, take an example. So, this is the complicated circuit. This is resistance R1, this is resistance R2, EMF E1, EMF E2, and this is resistance R3. Now, how is the current circulating? Current will start from positive terminal, it will start moving from positive terminal. So, this is current I1 of the battery E1 and this is current I2 of the battery E2. This current I1 will approach here, I2 will approach here and here. According to Kirchhoff's first law, this amount of the current which is coming toward the junction will be equal to the amount of the current which is moving away from the junction. So, this is the current which is moving away from this junction. So, this will be equal to I1 plus I2. Across this resistor, the same current I1 plus I2 will move and again the current will be distributed as I1 and I2. So, this current will go inside the battery I1 and the same amount of current will go inside this battery which is I2. Right? Now, I am naming the points A, B, C, D, E, F. Now, to apply Kirchhoff's law, I require to take a closed loop. Right? So, what closed loop am I taking over here? I am taking a closed loop which is A, B, C, F, A. Now, what are we doing? We are applying Kirchhoff's law. And how am I tracing the circuit, tracing the loop or traversing the loop? I am traversing the loop in clockwise direction, in this direction. Let us start from A. While traversing the loop from point A, I come across the resistor. Yes. Am I moving in the direction of the current or opposite to the direction of the current? I am moving opposite to the direction of the current. So if I am moving opposite to the direction of the current, then the potential difference across this resistor will be considered to be positive. So I can write I1 into R1, right? Okay, now while traversing the loop, am I coming out of the positive terminal of the EMF or the negative terminal of the EMF? I am coming out of the negative terminal of EMF. So that means this EMF will be considered to be negative. So this will be minus E1. Again, across B, C there is no component. While moving from C to F, I get R3. Now, am I moving in the direction of the current or opposite to the direction of the current? I am moving opposite to the direction of the current. That means the potential difference across this resistor R3 will be considered to be positive. So it will be plus I1 plus I2 into R3 is equal to 0. So I can simply write this equation as E1 is equal to I1 R1 plus I1 plus I2 into R3. So this is equation number 1, right? So this is how, by using Kirchhoff law, if any of the unknown value, if there is any unknown value, let's say for example, I don't know what is the value of EMF, I can find using this equation. I don't know what is the value of the current, I can find using this equation. So this equation, as I told you earlier, Kirchhoff law is used to find out the unknown value of current, unknown value of EMF, unknown value of the potential difference across a resistance, right? So using such kind of a equation, we can find the unknown value, right? Take another example. I am taking another loop. Let us take this loop, bigger one. So it is A, B, C, D, E, F and back to A. Let us again trace this loop. Now this time we will trace the loop in anti-clockwise direction. Will it make any difference if I am tracing the loop in clockwise direction or anti-clockwise direction? No, it will not make any difference. We will get the same answer. So you can trace the loop either in clockwise direction or in anti-clockwise direction. So I am tracing the loop in anti-clockwise direction, this direction, right? Okay. Now let us start from point A. From point A, I am moving to F. Is there any component? No, there is no component. From F, I am moving to E. Is there any component? No, there is no component. And then I am moving from E to this E2. What am I getting? R2. How am I moving? In the direction of the current or opposite to the direction of the current? I am moving opposite to the direction of the current. That means the potential difference across this R2 will be considered to be positive. So I will write positive I2 into R2. Now this EMF battery, along what terminal am I coming out? From which terminal am I coming out? Positive or negative? I am coming out of negative terminal. So this EMF will be considered to be negative. This battery will be considered to be negative, minus E2. From D to C, is there any component? No. From C to B, is there any component? No. From B to E1, is there any component? No. From now, from which terminal am I moving out? Coming out of this battery? I am coming out of the positive terminal. So I will write plus E1. And then, am I going in the direction of the current or opposite to the direction of the current? I am going in the direction of the current. If I am going in the direction of the current, then the potential difference across the resistance R1 will be considered to be negative. So I can write it is minus I1 into R1 is equal to 0, right? So even in this particular case, what are we getting? We are able to find the unknown EMF. If at all we don't know any of the unknown EMF, we can find out the potential difference if at all we don't know the potential difference, right? So ultimately, I can say that the summation of changes in the potential while traversing the entire loop, closed loop, will be equal to 0. So this is nothing but Kirchhoff's second law, right? Let us take an example of Kirchhoff's second law. Cut.